Well, good morning, everyone out there in internet land. Good morning to Cody from North Dakota. Good morning, Nicole. Good morning, Robert Wolf, Ron Webb, Sierra Stacy. We have a lovely looking group joining us this morning. My name's Arthur Ward, and I'm the Director of Distribution with Aberhart Ag Solutions. And I want to welcome you today to our seminar on why BioSul is the Chuck Norris of sulfur. As we all know, Chuck never gave up. He might have been missing in action, which we're finding sulfur is today in our fertility at times, but he always comes back. Sulfur is an integral part of our fertility. It drives what other nutrients can do, and BioSul is one of the most economical and bio-friendly forms of sulfur that we can use in our fertility program. Today, I am joined by the legend, Greg Patterson from A&L Labs, and by Mr. BioSul himself, Cale Brown, who is joining us from sunny Alberta. Greg, why is sulfur becoming a bigger issue now than in the past?
Well, I go back a few years. I started in this industry in the late 70s, started my lab in 84. Sulfur's always been a concern. Right from that day forward, because we do a lot of stuff with potatoes, we could never get enough sulfur on a potato crop. That's where we started our research. We know that when we look at tissue samples, of all the nutrients and all the tissue samples we brought in lab from day one, sulfur by far is the most limiting nutrient. It's very seldom we see a sufficient level of sulfur in our soil tests. I used to put presentations on sulfur in my agronomy seminars and looking at the optimal level of sulfur is someplace between 14, 18 part per million. And in my seminars, I'd always say, guys, you got to have at least 25 because we don't see anywhere as close to sufficient levels in tissues on all crops until we're above 25 in the soil. We really didn't understand where those levels are established at because they were always deficient. And we know that our soil our soils are deficient right across the country. I made a statement a number of years ago that we're deficient in sulfur and why, and the seed end sulfur ratio in soils, and why it was important. I wrote a tech bulletin in 75, and right away the whole academic community came at me saying I was nuts because acid rain was giving us lots. And I said, well, we're getting lots. I'm not seeing it in crop production or in the quality we're looking for. And, that went on for years and years. About 4 years ago, 5 years ago, all of a sudden the academics started coming back saying, we need sulfur. I don't know if you, Cale, you've seen that or whatever, but so did they wake up one morning with such premonition that we need sulfur? No, the World Trade Organization spoke out and said that we need to have lower acrylamides in our processed products, and we can't get that without sulfur. So all of a sudden, sulfur becomes an important nutrient because if you're low in sulfur in a plant, the plant accumulates asparagine in the crop that when you process it converts to acrylamide. So I mean, it's an issue with human nutrition, acrylamides being carcinogen, and we're starting to get pressure from other countries where we export a lot of grain to, that our grain that we are exporting is low in sulfur and converts to acrylamides in processing. So a lot of the push was from the consumer side that made us wake up and say, hey, what's going on here? And I'll show you some tables and maps on where sulfur levels are across Canada and North America and the real deficiency we have. So I recommend a lot of sulfur. I don't, and there's two ways of putting sulfur on. One's for acidulation to make nutrients more available. The other is just for plant nutrition. So we need to understand what role sulfur plays in crop nutrition and overall producing a decent economical crop. I'll try to speak to that as we go forward. There's more to sulfur than a lot of people think. It's not as readily available. It's not in the soils. And I'll show you some maps and charts and kind of help you understand that.
That's interesting, Greg. When we think of sulfur, we think of plant nutrition or the plant's ability to use other nutrients, but not actually how it affects the final product in processing. Interesting that, it's not only where we seeing sulfur deficiency in the plant and then the performance of the plants, but also in the finished product as well.
I'm a bit of a homeopath and always have been. My first wife died of cancer and I got pretty actively involved in it. When I put my seminars on and talk about nutrients, I always try to put the human nutrition piece to that nutrient. I mean, good evidence now in North America, a lot of our Alzheimer's and dementia is because we do not have enough boron in our diets. Our soils are boron deficient. Prostate cancer, breast cancer, brain cancer, we don't have enough zinc in our diets. The issue with magnesium deficiency in our population is horrendous. Anxiety, miscarriages, hypertension. We're just not getting the right nutrients, and the crops we're growing don't have the right complement because our soils we grow them in do not have the right complement. So I think as we go forward and people start looking more at nutrient density worldwide, you are what you eat. There's going to be a lot of emphasis on how we put a crop together and how we feed that crop so that we can get the food we need to support some of these health issues we have worldwide.
And that's the sulfur deficiency in our soil. It's not unique to Western Canada, is it, Greg?
It's worldwide. I'll show you a chart. The
Sure.
fact that we're taking more out of the ground in sulfur from crops we grow than we're putting back.
Sure. Let's have a look at that information. I think we've got some great questions leading into that.
You want me to share my slides?
Yes, please. While Greg's doing that, maybe Cale. Oh, saved by the bell, maybe Cale.
You see that?
There we go. You bet.
Okay.
We can now. Thanks, Greg.
Okay. You want me to go ahead? Or
Yes,
Cale
please.
wants to?
You bet.
Okay. So we're going to start off with just looking at Mulder's chart. When we put fertility programs together, we have to pay attention with the interaction between the different nutrients. You don't see sulfur in this chart. That's because sulfur's a good guy. Every time we put sulfur on, it increases the availability of pretty well every other nutrient. It helps us with nutrient uptake with all the nutrients, except for molybdenum. If we over apply sulfur or apply copious amounts, which I do in a lot of crops, it can tie up molybdenum, especially in a soil that's low in moly. But it's easy to correct. I usually put on 4 to 6 ounces of sodium molybdate pre-plant, and that's all looked after. For the most part, sulfur is actually going to help the uptake of all the nutrients we put on and the process of the nutrients within the plant. It's kind of that catalyst or key ingredient. And then we look at removal, and I don't think we pay enough attention to this. You look at the removal of nutrients, I just got a few here, but you see that there's a significant amount of sulfur taken out of these crops. You compare sulfur to magnesium uptake, and it's very close to what we'd take up in a crop with magnesium as well. So there's a significant amount of sulfur this crop's removing from the soil. We're going to talk later about how soils retain sulfur and how it becomes available to crop, which a lot of people don't understand. The biggest concern we have here is the global use of sulfur. The yellow line on the top is a crop requirement. You can see this is an old chart, but back as far as 2006, from 1991, we're taking a lot more of sulfur out of the ground than we're putting back. So there's a natural deficit of sulfur in soils to start with, and then we don't put enough on to meet even crop removal. We got to pay more attention to that because it's becoming a global problem. We look at sulfur in the environment. A lot of people talked about sulfur coming from acid rain. We've done studies on sulfur taking out our sugar bushes in Ontario, and did a 3-year study on that. The government subsidized both in the U.S. and in Canada. Both in the U.S. and Canada, they stopped the study after the first year because they found out the acid rain was not the problem with the decline in sugar bush. It was just the fact that we're sucking the life out of these trees with this new technology of vacuum lines going from tree to tree, and we weren't feeding the trees. So there's a lot of things that we do in our environment we blame other things for, and we just got to pay more attention to that. As we continue to clean up our emissions, sulfur becomes less of an issue. I'll show you a map here in a minute that shows that correlation to cleaning up our emissions and what it did to fall to sulfur in North America. So you look at this map, this is an old map, 1989 to 91, and you can see the levels of sulfur in the more industrialized areas up in that 30 plus range. And this is a map of the US, but you can extrapolate those lines right across into Canada. And the blue zone shows you that we have sulfur levels in soils that are actually quite deficient. And they got worse in 95 to 97. And then when we take that map out, you can see how it is even in 2001. And that's as far back as I got this information. But when you look at this sulfate availability in soils, again, I said earlier, I want to have sulfur levels in soils over 25 parts per million. And there's not very much of the U.S. here. Extrapolate that map across to Canada. There's not very many soils that have over 25 parts per million of sulfur anywhere. So this is a concern. If we're not putting it back and we're taking more out than we're putting back to start with, and we're deficient to start with, we've got a major problem. This is when we look at quality, grains we produce to produce bread. Sulfur plays a major role in the quality of the bread. Fixation of legumes, fixing nitrogen in soils and soil bacteria depend on sulfurs. It plays a major role in photosynthesis in plants. A lot of the quality aspects of the crops we grow and the oil quality in these crops is all part of that whole sulfur piece. And then a lot of the other things that happen, and as I said, has a lot to do with enzyme formation within the plant and a lot of the catalyst of a lot of things that are happening in the plant that the plant depends on. This is a tech bulletin I put together back in '85, and I sent that out. I got a lot of ridicule because I was talking about how dependent we are on sulfur, the fact that we need sulfur. That article talks about the amount of sulfur that's required to break down the straw we plow back into the ground. So if we want to get the good out of the residue we plow down, we need sulfur to break that down. We just don't have enough residual sulfur. And then when we plow down heavy crops of straw, a lot of that sulfur that's needed for the crop is tied up in breaking down that straw. So there's a lot of things that we do that reduce the availability of straw. Now, the things like compost materials, when we put sulfur on, in the case of BioSul, the microbes that break down the sulfurs and make sulfur more available, that's a natural environment for these microbes. So the combination in this case with the BioSul, compost, and sulfur is a great environment to be applying sulfur and have it available to the plants. This is the chart I referred to when we first started, looking at how the plant accumulates asparagine when we have low sulfur levels in soils. When we process the foods, be it a potato for potato chips or grains for flour, we actually accumulate acrylamides when we have low levels of sulfur or high levels of asparagine because of low levels of sulfur in that crop. So it's something that's becoming recognized and why there's a real push towards recognizing sulfur as a missing ingredient in crop production because of the impact it's having on our processed foods. We need to understand the sulfur cycle, and we can apply sulfur a number of ways. And the issue here with sulfur is people believe that sulfur is leachable. And I'm going to show you some work that was done, not by me, it's Teasdale and Beaton, I believe, started looking at how sulfur is attracted to the carbonates in the soil, and that we have to get to a certain level of sulfur in soils to satisfy that fixation, if you will, before it becomes available to the plant. So it's not nearly as leachable as we think it is. And we can build it to certain levels to make it available to plants, but we need to understand what that level is, and we need to be putting on enough sulfur to get there, because for the most part, we're not putting on nearly enough sulfur. I've seen sulfur trials done on crops where on alfalfa, there's one done not too long ago here in Ontario, where they're putting 5 to 10 pounds of sulfur on the soil to see about response to an alfalfa crop. That soil was already so deficient in sulfur, they didn't even get close to satisfying that deficiency. Their conclusion was there was no response to application of sulfur. They just didn't get there. And that's the type of things we have to think about when we do these trials. What is the necessary amount that we have to put on to satisfy, first of all, the combination of the carbonates in the soil that will tie up this sulfur, and then just what level do we have to get to and how much do we have to put on.
So, Greg, when we talk about a product like BioSul, if we have an inherent sulfur deficiency, like we're seeing, if we've increased production through plant technology, through other fertility programs, as we grow these bigger yields and we are creating more organic matter, it's tying up even more sulfur, or there's less sulfur available in the soil for the plants to grow. So, when we start a program with a product like BioSul, the keys would be to make sure you do good sampling to find out exactly what's there, and then kind of front load or supercharge, I guess, for lack of a better term, that first application to make sure that you're correcting that deficiency before you expect to see response.
It's not necessary supercharging. In some soils in Western Canada, particularly with high mag soils where your base saturation of magnesium might be north of 25%, magnesium is a particular carbonate that really fixes sulfur. That combined with potassium and calcium, you might have to put on 60 pounds of sulfur. Now, what kind of application of BioSul would you need to put down to get 60 pounds of actual sulfur?
You basically need roughly 500-ish pounds to get 60
Okay.
first year, which
Yep.
is pretty heavy application.
Yep. We're not there. People look at the economics of putting it down, and you might put down 300 pounds in a soil that needed 500 pounds. A grower might come back and say, I didn't really see a response. I really didn't see it did anything. Well, you didn't get there. You didn't put enough on. So first thing you have to know is what is the soil I'm working with? And I'll show you a soil test later, and every soil is different. And we've done the research on the carbonates, and we know there's some more research on the aluminum component that we don't account for in our recommendations. And there's another one we're still working on. We just don't have a big enough data set, and that's sodium. You've got some sodium pockets in Western Canada that could be north of 1,000 ppm of sodium, and you'll have 400 or 500 ppm of sulfur in those pockets, and you're still sulfur deficient because the sodium has tied that sulfur up so tight the plant can't get it. So we have to understand these relationships and understand what are we looking at and what are we trying to overcome to make sulfur available. Did that make sense?
Absolutely. And just a reminder, everyone, if you have any questions for Greg or for Cale, don't just throw them in the chat, and we'll get to them as we're going through or at the end. So, Greg, my hometown's Chaplin, Saskatchewan, where it's right along the #1 highway. And we have a sodium sulfate plant there. So if you've ever driven the #1 between Moose Jaw and Swift Current and seen that ski hill in the middle of summer, it's a big old pile of alkali. So we're very familiar with sodium tying up everything in the soil.
Well, and particularly sulfur. And I've got like potato crop. When I make a recommendation for potatoes, I'm going to tell a guy to put enough sulfur on. I want 100+ pounds of sulfur go down on an average potato crop, for 350 hundredweight. Not many people are doing that. Now, they do it by mistake sometimes. They'll put on some potassium sulfate and maybe some gypsum. And their concern is, I'm getting high in sulfur. What's too much? Well, in a potato, you can't get high enough. It's just how the plant uses sulfur. I want 1-to-1 sulfur to phosphorus in my tissue sample, and I fight to get there. And it's not the only crop. A lot of the fruit crops I deal with, like strawberries, I want high levels of sulfur in strawberries. And again, I don't want a sulfur that is going to acidulate soils. I want a sulfur that is a nutrient, not just an acidulating sulfur. When you put BioSul on, just the nature of BioSul with a compost, you're nullifying that acidulation. So there's things we got to think about when we use sulfur and how we apply it and what we're trying to accomplish as a nutrient. This slide here talks about how sulfur plays a role in the proteins and amino acids within the plant and how a plant puts all this together. And we don't think far enough ahead to think about things like the synthesis of oils in oil plants, the respiration process in plants, sulfur plays a role in, nitrogen fixation in legumes. And we talk about the formation of ATP and how important phosphate conversion is in that, and the role sulfur plays there in the uptake of phosphorus. So there's a lot of issues. When we look at sulfur deficiency, we see generally yellowing of leaves, usually no necrosis of leaves, reduced or stunted growth. Yellowing is uniform throughout the plant. But oftentimes, this is a corn plant, oftentimes when people see this, they right away go to nitrogen deficiency. So the knee-jerk reaction is, I need nitrogen. Well, it's sulfur. And not diagnosing what that is, the corrective here was more nitrogen, which could further induce more sulfur deficiencies. We need to recognize it and understand what it is. In wheat, we see this oftentimes, and a lot of people right away, because yellowing of plant, everybody relates to nitrogen, they would think that's nitrogen deficiency, and they would not even think about sulfur. Just what we see in canola all the time, that's sulfur deficiency in canola. Can we recognize it? A lot of people look at that and say, that's phosphates. The recognition of what we're looking at is important. And we see, particularly canola crop, because it's an oil crop, huge dependency on sulfur, and we're just not there. So, I put these slides up because we've all seen this, and we all usually point at the wrong thing on deficiency when we talk about sulfur deficiencies. Made worse by a number of things: low organic matter soils, high rainfall, cold, wet soils. Cold, wet soils and high rainfalls are attributed to a lot of problems like potassium availability. High carbonates in soils. This is the biggest one. Calcium, magnesium, potassium are carbonates, and they tie up sulfur. And a lot of people don't realize that sulfur gets tied to these carbonates, and we have to satisfy that concentration of carbonates in these soils before we have enough sulfur to be available to that plant. That's when we make recommendations, what we use now to give you a recommendation to build sulfur levels in your soils. When you have anaerobic soils, the microbes that make sulfur available aren't functioning. So your sulfur, even if it's in the salt, even in the case of BioSul, if you put it on and plowed it down, the ability for those microbes to make the sulfur available just isn't happening. So we need to understand how that works. So again, when we look at sulfur being an important element for crops. Also, the issue with environment. We got to pay attention to our plant nutrition. This nitrogen to sulfur ratio is important. Acid soils 10 to 1.2, and calcareous soils 1.5, podzolic soils 1 to 3, and chernozem soils 1 to 5. Each soil type is different. It comes back to these carbonate combinations that we have to be effectively looking at. When we look at, this is particular looking at potatoes, the amount of sulfur putting on, you can see here, it's not till we get up north of 45 pounds of actual sulfur to the acre that we actually start getting any kind of response or quality response in these crops. And that's why I say this particular crop I've done a lot of work with, and I want 100 plus pounds of sulfur put on a potato crop just to get what I'm looking for. I'm not even talking about the chipping quality or the reduction of acrylamides, just to get the production I'm looking for. We say that sulfur increases nutrient uptake, and it does that for a number of reasons. This is a soil sample where I've educated my people to look at the hydrogen ion concentration on a report. And if you're below 5, we need hydrogen to take up in the soil to help take up phosphorus, nitrates, and sulfates. That has to be there because hydrogen is a companion ion to take these nutrients into the plant. And so I make recommendations for sulfur, not just as a plant nutrient, but I have some acidulation happening there to help the plant actually do this. Plants naturally acidulate to make this happen, but in calcareous soil, sometimes that's difficult. So we look at how plants convert phosphate to energy. They take up a potash and put that inside the plant to start that osmotic pull of nutrients into the plant. But that takes energy. That energy comes from the conversion of phosphorus from ADP to ATP. And you can see here the hydrogen ions coming in to help that phosphate, that inorganic phosphorus, be taken into the plant at the surface, root surface, and then convert that to ATP, which is actually magnesium ATP. Sulfur or acidulation at the root zone plays a major role in how fast that happens. You can see here on the left-hand side how the companion ions of hydrogen help facilitate the movement of phosphate into the plant. Over on the right-hand side, the plant is actively trying to acidulate that zone to make that work. Adding sulfur to our fertilizer bands or our application of fertilizer in early spring helps move that phosphate in the plant faster, which gives us more energy and better plant growth, particularly in cold, wet springs. So we have to understand this is a mechanism in the plant and how these nutrients play together and how important they are for certain things to happen in the plant. When we look at sulfur levels, it used to be when I put on my presentations, I would tell you that even though the charts in our books at the time said 14 plus was sufficient sulfur levels, I'd always tell people in my seminars, I want to get you north of 25 because we're not seeing sulfur levels show up in tissue values to the level we want. We're always on the low side. If I want, particularly in potatoes, I want 1-to-1 phosphorus to sulfur in my plant tissue right through the growing season. And we struggle to get there. As a matter of fact, we don't often get there. This is right out of our books back in the day. This is our charts and tables. You can see there's a rating. You pick up any handbook in North America, you're going to see the same chart. Everybody uses the same thing. It's basically saying all soils, this is where the optimal levels of sulfur should be. Everybody says sulfur leaches. Well, it does. But it doesn't until you satisfy this carbonate issue that I'm talking about. So our old ratings would look like this. But now today on the reports, we can't give you a chart and table. Every soil test is different. We now have some consultants that actually variable rate apply sulfurs based on the recommendations and the soil information they're providing. That was the old recommendation. This is what that same soil test would look like with the new recommendation. So that 13 that was in the higher range, medium and high range, is now very low in that particular soil type. When we look at sulfur nutrition and how important it is, we need to balance the sulfur, carbon, and nitrogen ratio in these soils to make sure the system's working. And again, for optimum production, sulfur should be in the good to high range all the time. And every soil type now at our laboratory is rated differently. So you look at these soil types and why the differentials. You look on the left-hand side in the sulfur levels and you see how those vary. You can see at 13, one soil is very low, but at 15 on the bottom soil, we're rating it as high. If you look at the carbonates, the potassium, magnesium, and calcium in those soils, that combination of those three particularly will tie up sulfur, and that's why that rating is there. When we do a soil test, we take that rating, we take the 13, we calculate what the optimum level would be for that soil. In that particular soil, it would likely be about 35, and we subtract the 13 from the 35, and that's how we make our recommendation for sulfur to get you to a level that sulfur is going to become available to the plant. Now, that would be a recommendation for average soils, but if you're growing a crop like canola or any brassica that has a high demand for sulfur, I'd still add another 5 to 10 pounds of sulfur on top of that just because of the demand that crop has for sulfur. So the top one, 17.5 CEC, the optimum sulfur on that was 39. The recommendation would be 39 minus the 13 is 26 pounds of sulfur. If I was growing canola, it would probably be 35 to 40 pounds of sulfur to grow that crop, if that makes sense. Any questions on that? We can't give you a chart and table on how to read the sulfur recommendations. Every soil is different based on not just the crop you're growing, but the clay content in that soil, the carbonates in that soil. Our research has gone this far with carbonates, but there's still a lot of research out there on aluminum. Now, it doesn't affect a lot of you in the West because you don't have a lot of high aluminum soils, but in the East we do. And sulfur is tied up by aluminum. There's a researcher out of BC that was doing a lot of work on that a number of years ago. That research basically stopped, but that's another area we need to work. And we're now doing more research going forward with our sulfur, looking at soils with high sodium contents and what is the relationship there and how it's tied up by sodium. And again, something to think about. So when we look at sulfur, what's happening here is, in this particular case, the top one, I have to get to 39 part per million of sulfur before I have enough sulfur that the crop starts to see it. So it's basically tied up in this soil, and I have to satisfy that reaction before sulfur can spill over the top to make it available to that crop.
So when you're talking about the sulfur levels in the soil and looking through the soil tests and seeing what's there, and then when we look at your recommendation, Greg, on what we add on, is it to get it to what's available for plant use, or do we add, you suggested more than that, but I'm just wondering, if we say, layman's terms, we need a canola crop uses 30 pounds of sulfur in a year, and that 34 pounds is getting us to where it's going to be available. Is that, in theory, do we need to add that 30 on top of that?
You need that yet. In the case of conventional crops, if I added 26 pounds on that top report to most crops, I would have enough sulfur over and above that. With that level, I get sufficient sulfur in the plant. If that was canola, like I said, that would be a 36 to 40 pound recommendation. The bottom one is satisfied in the sulfur levels at 4 pounds or 4 ppm. But again, if it was canola, I'd be putting on 15 to 20 pounds of sulfur just to satisfy that crop. So we need to keep in mind the recommendation is for general crop production, but when you start looking at crops like canola, and we put that recommendation together when we give you a recommendation on our crop. If that crop come out to the rec of 26 for conventional crops, I would add another 15 pounds of sulfur to that recommendation for canola. Right. If that makes sense.
Yeah, okay. It does. And I guess that's just one of the, if we're looking at it from a reclamation standpoint, where we are severely deficient already, we need to front load a little bit or get to that minimum level of sulfur, then for plant availability to see an impact or a change in that crop. If we don't add what we're short plus what we need to use, we're still not going to get the true benefit.
Right. Let's relate this to nitrogen in the West. You guys do a good job of looking at nitrogen availability and soil tests for nitrogen. A lot of guys now are a VRT and nitrogen across field based on a more site-specific approach to it. Sulfur's no different. We build sulfur levels up to where we want. In this case, you see 39, 24, 34. So we want to build it to those levels, and they will stay there. They don't leach away because it's tied to these carbonates. Then we need to put a little more on for the crop. And that's a consistent thing. We have people that actually do this. They'll write a variable rate application map to look at how much sulfur they want to apply to satisfy the needs for that crop going forward. Sulfur leaches, but it doesn't leach like nitrogen. It leaches much slower than that. It is held to the soil particle much tighter than nitrogen with these carbonates. If you put a broad application of soil on a field that was going to apply maybe 20 or 30 pounds of sulfur, you're going to miss it on some areas of that field, and then again add to that the crop you're growing, if it's canola, you're going to be way off the mark. We need to do a better job of understanding this variability and how this sulfur is reacting in these soils when we start applying the technology we have today, if that makes sense.
Absolutely. To your point, the first step whenever we're looking at fertility is to understand the medium that we're working in. So what soil type do we have, and what are the inherent levels of minerals, and apply products according to what the recipe is for that, and not try to do the old broad stroke of we're going to put 100 pounds in on everything, and when you don't really know if it's helping or not.
Right. Looking at tissue samples over many years and always trying to get that sulfur level, we knew we had the crop quality and yield we were looking for when we had that phosphorus and sulfur balance in potatoes, and just trying to understand why it was not happening. And having soil tests with 13 to 18 part per million, which is always rated high, why aren't we getting that crop? And then just observations was showing me that in those soils, again, they were sandier soils with lower carbonates. Anytime I was north of 25 part per million in these silt soils, and CECs in the soils was anywhere from 9 to 15, I would see the response. I would see sulfur show up in the tissues, but not until I got to that 25 ppm. And people weren't applying a lot of sulfur. At that time, the potash sources were primarily muriate of potash, no sulfates. We'd put some gypsum on, we'd see some sulfur response. We'd go to a K-Mag product, had a bit of sulfur in it, we see response. Potato growers were not typically putting elemental sulfur in the planter mixes because they're always dealing with low pH soils. So we got to understand, what does a crop need, and how are we dealing with these soils, and where does it make a difference?
Greg, when we're talking about, we look back earlier on the slides you had on the plants and that yellowing, and the assumption that we've always made that it was a nitrogen deficiency or something as opposed to sulfur. When we're seeing that sulfur deficiency in that new growth on those plants, are we too late? Can we correct it, or we're too late?
No, you can correct it because sulfur is very mobile. How are you going to put it on? Now, in a lot of cases, I use sulfate of potash magnesia, and I'll see it green up right away, but it's both a magnesium and a sulfur response that's making that happen. And a lot of times, it's more the sulfur response than the magnesium response. People don't give the sulfur the credit. If you see a yellowing and you can definitely say it's sulfur, you need to react because you're losing yield and quality. Okay?
So we just need to put enough on in the beginning.
Well, yes, but that doesn't always work. I mean, in environmental situations, rainfall, all that kind of stuff, we might think we put enough on, but we still have Mother Nature, and then understanding the different soil types that we're dealing with. I got here listed how it's tied up by these calcium and magnesium and sodium complexes. And then again, how sulfates are tied up similar to phosphates, absorbed to these clay materials. And again, not as much as phosphorus and not as tight as something like phosphates, but sulfur is definitely tied to these clay components. And the different clays we deal with respond a little bit differently. We don't have all this figured out with all these different soil types. Some of our recommendations and our understanding is still fairly general. We haven't broken it down exactly by clay components, but Teasdale did back in the day. And I don't know why they didn't take it further to plant nutrition, but they showed that sulfur was being tied up by these carbonates. Let's say I got a magnesium soil that's got over 20% saturation of magnesium. Not only am I tying sulfur up in that complex, it's an anaerobic soil, so sulfur's not being released because the microbes aren't functioning properly. So there's a whole bunch of things that restrict sulfur uptake that we really don't account for.
And in a case like that, the BioSul product with the compost would help address.
Well, I'm saying we do a lot with compost, and we do a lot with microbiology. We have biostimulants and everything else, and we're dealing with compost companies now that we're saying you can make a better compost by adding a microbe to it. So in BioSul's case, maybe you need to start looking at putting a bacillus or a pseudomonas with the BioSul to give it that extra boost for crop stimulation. Compost is an excellent haven for these biologicals. It protects them from the environment. It's a food source and a great way to deliver them. And that's what your BioSul does, has natural microbes in it already that help break down the sulfur. So when you put sulfurs with the BioSul, you've got a great combination here that you're seeding the sulfur with microbes that will naturally start breaking down the sulfur when you put the elemental sulfur with it. So it's a great fit. And I don't know why more compost companies don't use compost as a delivery mechanism for a lot of microbes.
Right. Greg, you raised a good point on a couple of occasions here. I just wanted to slow you down because I'm taking notes here myself with some of this stuff because it's Yeah, you're the wizard when it comes to soil sciences. I wanted you to touch on testing and soil testing versus tissue testing and having an effective sulfur tracking system. I think that's something that a lot of guys struggle with because sulfur is so soil mobile, right? So you hit a sulfur core 1 year in your soil sample and it cranks up the average on your whole field. So I just wondered if you could touch on how to accurately test for soil conditions, what you're actually working with. And you've already talked about always making sure you got more than enough for canola, but just in the testing procedure, if you could touch a little bit more on that, that'd be great.
Well, last week with Dan's podcast, we talked about soils and soil testing and the ideal soil testing process. We still have a lot of people that take a bulk soil sample, and that's what they use. A bulk soil sample across, if it's only a 50-acre field, is 50 acres of average variability, which when you put in a pail, you really don't have a good answer. A lot of people say, well, we'll do zone sampling. Zone sampling is just a modified bulk sampling where there's so much variability in these soils that a lot of times you don't get the real answer. And then we have the question, what is the right amount of soil sample? So there's a paper I delivered last week that talked about where an independent research group did soil sampling on different grid sizes, and they come out with less than 1 hectare per sample is ideal no matter where you are, the ideal rate for site-specific sampling. And the economics in doing that with the proper application of fertilizers and the understanding of variability that allows us to apply these fertilizers in the right rate showed up to be the most economical way of doing that. Regardless of how many samples that generated. And I'm not here trying to sell you samples, but we deal with this every day. Without understanding the variability, how do we deal with this? How do we know if we got a response to that product or not? It might not have responded over here, but we saw some response here. The variability in soils is horrendous. I had a consultant a few years back that asked me about a problem he was having in Timothy under a pivot. I said, well, what did the soil samples tell you? Have you site-specific sampled that field? He said, Greg, you don't understand the West here. It's flat land. There's no variability. I said, humor me. And he went from a silt soil to a heavy clay under that pivot, and there was so much variability that was his problem. He didn't understand and wasn't managing the variability. In order to do the things we want to do in production agriculture today, fertilizer is not getting any cheaper. And we're throwing it around like it was the same price as it was 20 years ago. That's not the case. Even nitrogen. We can overuse nitrogen and that reduces yields. And yet we have blanket rates across a lot of our fields based on one soil sample in a section or a quarter section. We really aren't paying attention to variability. Sulfur is no different. I mean, you might go from an application of 300 to 600 pounds of BioSul across the field based on some of this information. You take your input dollar and spread it where it's needed rather than waste it in one spot and not put enough in another. So I think there's some real potential for a VRT application of BioSul in this case, or any sulfur material. So it's, first of all, identifying what the variability is in the field. You may never do that field that way again. Sample every 2.5 acres. You might, once you have an understanding of variability, you might just go in and take 3 or 4 samples in that field based on strategic points, and then, develop your VRT rate based on some kind of algorithm that divides it over what you took on the original samples. We're not doing a good enough job of understanding the variability. A lot of products are used or misused because we didn't see a response because we didn't identify some of the variabilities and what is the optimum level. I mean, we've got people every year call us up and say, I don't believe your nitrate test. You're too high this year. You're too low this year. Well, they took maybe 4 samples in a quarter section to make their nitrate recommendations. Last week, I showed variability in nitrogen across a field we did at the Ag in Motion show in Saskatchewan. The variability was wild. And it wasn't just that year. That variability in nitrogen is in that soil every year because of natural nitrogen release from organic matter. So if you didn't sample exactly the same spot every year, you're not going to get good information year over year because of that differential. So we don't do a good enough job understanding the variability of our soils when we're looking at application of any nutrient, not only sulfur.
Yeah. So what would your one piece of advice regarding sulfur, Greg, that you could give to our listeners today? What would that be?
Well, we need more sulfur. We're not putting on near enough. And you're going to get crop response. We see it all the time. Western growers are more in tune with it than Eastern growers. You guys are starting to use a lot of sulfur because you're inherently low in sulfur right across the West. So we always see sulfur response. Yeah. There's less reluctance, if you will, from so-called experts about sulfur use today because we've seen so much of it used and so much response, they can't negate that. Plus, they're getting information from the World Health Organization on this acrylamide aspect. We actually had exports refused a few years ago because we were known as having high acrylamides. Anyhow, we've moved beyond that, but we still have to identify it because it's become a topic of controversy in a lot of areas. And we just need to pay attention to it. So that's just showing a slide on sulfur absorption by different soils, and we need to understand that. But again, not just the clay content alone, the amount of those carbonates in those clays. This is some work we did in our research trials looking at traditional sulfur extractions compared to our extraction we're using now. The problem with the traditional sulfur extractions is they max out about 400 part per million and start maxing out before that. The extraction we use now doesn't max out. So we can give you a sulfur recommendation right to 2000 ppm if it was there. So we've really tuned in on sulfur availability and understanding the sulfur levels in the soils you're dealing with so that we can deal with this and we can give the right recommendation and right information on why we might have a production issue, right, if that makes sense. Again,
absolutely.
This is coming from that third edition of Teasdale and Nelson, if anybody wants to look into it. When I started looking at the sulfur research, I looked into every piece of literature I could find in sulfur, and I come across this one. And this is where they identified that we first have to satisfy the absorption levels of these soils to sulfur. And you can see these lines here, the different absorption of sulfur to different carbonates in these soils. And it's not till we get to that top line in concentration of sulfur that sulfur is actually available to the plant. So think about it as a bucket. We got to keep filling up that bucket until we get to the top before we get sulfur spilling over that's available to the plant. That's kind of a simple analogy. Understand what we're trying to do here. Now, you're not losing that sulfur because it's bound by those salt particles. But once we get to these optimum levels, when we put sulfur on, we now get plant availability. If that makes sense.
Absolutely. That was a great presentation on sulfur and what we're doing. Cale, if I can, I'd pass it over to you. I have a couple questions for you just on when we look at BioSul in particular as a form of sulfur. How does it deliver on building up those sulfur levels or being plant available over the long term?
Just before I answer that, I thought maybe for BioSul's been around for a while, but just in case, for those of you that don't know, the BioSul 70% elemental sulfur and 30% compost. So that's manufactured all out of Hannah, Alberta there. We service Western Canada out of that pile. We use Class A compost, which is where GFL, the waste management company, comes in. It's all food and yard waste. There's a pretty high nutritional value in that compost. But to answer your question there, Arthur, it's all down to particle size, so variable particle size. With BioSul, just a general recommendation would be anywhere from 220, 250. It all just depends on your soil types and your yield targets and how much sulfur you're trying to deliver to the crops. But 120 pound rate, just for simplicity to use nice full numbers, you're basically getting 150 pounds of actual S. And because of that variable particle size, it's delivering roughly about 30 pounds to the crop every year. So that's what's going to be available with that particle size. You got everything from under 150 microns, which is, the size of the human hair, which is, the fines that are going to be available right away is basically as soon as it goes down, spring or fall, then all the way basically up to 3/8 of an inch, half an inch, right into that threshold there. And that's going to deliver that delayed release. So basically the way that we're able to deliver sulfur to the crop for 5 consecutive years is through that variable particle size. That's the key to the secret sauce there.
The other thing to keep in mind that you mentioned is you're applying this with a grade A compost. A lot of people think that compost generally is not regulated enough. GFL is a member of the Compost Council of Canada. They have to go through very strict rules. They are a customer of ours, and we're the compost lab for Canada. They send it in, we analyze it, and it has to meet certain criteria before it's a grade A. So they're doing their due diligence on the compost side too. Not only is it a good food source for the biology, but that compost, because it's leaf and yard waste, is also fairly high in potassium and phosphorus and other nutrients. A real complement of the micronutrients. So there's a lot of goods you're delivering in a balanced ration, not just to the biology, but the crop you're growing as well. Plus, even at 500 pounds of BioSul applied to the acre, the moisture retention is huge. So you're also benefiting from that application because even at that level, you're getting increased moisture retention. And I don't have to tell you guys how important that is for Western growers. So there's a lot of benefits to that whole combination that you're applying to that field.
Yeah.
That's a great point, Greg. It's not just sulfur. When we look at other elemental products that are out there, it's delivering, sulfur with some sort of a bentonite or a medium that's carrying it, where this is actually delivering other nutrients or other important properties to the soil in addition to that elemental sulfur. Cale, how maybe explain just to everyone what, like, on the logistics side, like, what is it, what does it look like? How do we put it on? That kind of thing.
Yeah, so we partner with distributors and applicators basically all over Western Canada. So essentially how it all would happen is if you decided, yeah, I want to check out BioSul. I mean, obviously you would call myself or Arthur or your rep in the area, you give them a shout and basically say, yeah, I'd like to try some BioSul. After that, we would organize everything for you on the logistics side. So, we would get it trucked out to organize the trucking on that side. Basically comes in usually 40-ton Super B side dumps is generally the preferred way we haul it. We use those to haul all over Western Canada. And then once it gets to the destination, we apply it through a spin spreader. Something important to note is, and something we talk about a lot is if you're like, hey, I got a little 5 or 6 ton spin spreader, that's not the spin spreader I'm talking about. There's a big limiting factor with BioSul, and it's the gate size and having a live bottom belt to feed your spreader consistently, especially because we're putting it down so heavy. The spin spreader that most of the guys are using in the network would be an agri spread, a 17 or 22 ton, so a pretty big pull type unit. And that way we're able to get the 250, 300 pound, depending on what your application rate is, up to 500 pound rate, the desired rate, and we're able to do that accurately. So with those particular units, we can spin it out to about 70 or 80 feet, depending on what the producer's comfortable with. The guys that we partner with are absolute pros. They throw pans before they apply BioSul and show you up. The distribution over the 70 feet is incredibly accurate. So that's a little bit on the logistics side. Did that answer your question there, Arthur?
How many pounds of sulfur are you putting down with 400 pounds of BioSul?
400 pounds, you'd be 56 pounds available into the first year.
Okay. It's a good slug, particularly with the deficiency you have. Like a lot of our soils coming back from Western Canada are in that 10 to 12 range of sulfur, where in a lot of cases they need to be 40 plus. So even with 400 pounds, you're just kind of getting there for the first year's crop needs.
And that's one thing we should point out too when it comes to BioSul. We're talking about the rate, but it is 70% sulfur. And because of that, the particle size, the bigger ones, as Cale mentions, the bigger ones take longer to break down. The smaller ones break down right away. When we talk about the rate, we talk on a per acre what we're spreading, but the sulfur that Cale is talking about is based on what would be available each year. So there would actually be there'd be 280 pounds of, like in that 400 pound example, there'd be 280 pounds of sulfur going down in variable sizes. However, it would be available over a 3 or 4 year term based on your needs. So the uniqueness about BioSul is it is a product that, because of that varying particle size and it does have maybe some different logistic challenges in other products, but it's a 1 in 3 or a 1 in 4 or 5 year product. Provided that you do what Greg tells you to do, make sure you have good samples, understand your soil, and know what you're deficient, and then put enough on there to be available. It's a multi-year product, so it isn't something that you're necessarily applying every year. We put it the fall ahead of our potatoes. On the canola, they'll apply that the fall before their canola rotation is typically how it would operate.
And the key here to remember that this stuff does not have to be worked in. Sulfur is not going to volatilize and be lost like nitrogens. It's best if it's left on the surface because it needs the air to activate. So some people would get concerned, well, I can't plow it in, I can't work it in, I'm no-till. No, it's best left on the surface, at least for the first period.
Great point, Greg. And that's where it does fit nicely into zero till, no till. For us on our potatoes, we would do our fall work and put that BioSul on top of that ground and then not touch it again until we do our field prep in the spring, just to allow that to do its thing. We've hit the top of the hour here. I want to thank Greg for sharing his knowledge and Cale for his knowledge at Eberhard Ag Solutions. We're big believers in sustainable or environmentally responsible products, and BioSul certainly fills that bill. If you do have any questions, if you're familiar with the product or you're not, or you've got interest in applying, this is right now, this is the time of year that we're putting it down. We do have product that's going out and going down every day right now. To Greg's point, fall, obviously spring works, but fall is better. So if you've got any questions or any needs out there, don't feel free to reach out to us. Go to our website at Eberhard Ag Solutions, and then you can reach us there, or find Cale on LinkedIn. Thank you, Greg. Thanks, Cale, and thanks, Eberhard Ag Solutions, for a great webinar. Wish you guys a wonderful harvest or spreading season. Thank you.
Bye now.